Hello, this is Raj Kamal, and I am an industrialization engineer in Cummins Meritor based in Lindesberg, Sweden. Cummins Meritor is a leading global supplier of drivetrain, mobility, braking, aftermarket, and electric powertrain solutions for commercial vehicle and industrial markets. With more than 110 years legacy of providing innovative products. We are an industrial partner in AI Plan for You project. Örebro University, being an institutional partner, is supporting us in this project to achieve the goals of AI Plan for EU. Cummins Meritor Lindesberg site produces fully dressed rear and front axle assembly for heavy vehicle applications. The plant contains both machining and assembly line. Cummins Meritor provided a concrete use case in flexible manufacturing domain. Cummins Meritor plans to use this as a starting point for the development of in-house solutions for workflow management in the Lindesberg manufacturing plant.
In this use case, we consider a component group named gear set composed of a gear and a pinion that must go through 7 or 8 steps independently before being assembled into the full set. Each step is processed on specific machines and take a different amount of time depending on the family of the gear set to be produced. Machining and department planners decide when and where to process each incoming order based on many factors such as family, processing time, availability in the machine, and so on. This is a difficult task which requires an advanced understanding of the machining process. In addition, changes in the situation, such as a machine breaking down or a new incoming order, are difficult to incorporate. In the AI Plan for You project, we aimed at making this process more autonomous to simplify the task of the human planners. Our planning solution takes as input 2 types of information. First, a set of orders that we call batches. Each batch specifies the family and number of axles to be produced. Second, it takes a stock of starting material and the stock of axles already existing for this family to ensure that the planning can happen and only the required amount is actually processed. The resulting plan will define which machine to use for each step as well as the temporal interval during which the machine is operating. The plan is calculated to parallelize work when possible, minimizing the amount of time necessary to satisfy all of the orders. As a result, our planning problem made use of numerical and temporal constraints of the Unified Planning Framework, and we used the planner Tamer to solve it. Our technology-specific bridge, developed by Örebro University, models the full use case domain through the Unified Planning Framework. The TSB is comprised of an interface, a domain encoder that contains the expert knowledge from the manufacturing process, a problem encoder that creates a planning problem based on the domain and the inputs, and links to the Unified Planning Library. Inputs are given through a dedicated web interface. In future development, these inputs will need to be parsed automatically from the other software currently used in Cummins Meritor. The input is then converted into the UP formalism to assemble a full problem, and the solution is parsed from the UP and distributed to the users through the same interface. Such a system, once fully integrated in the Cummins Meritor's process, would result in more efficient planning for machining. It would allow to adapt quicker to changing situations, such as a machine breaking down or new incoming orders. It is, however, important that the human operators keep control over the produced plan. Through developed interface, they can inspect and control the plan and ultimately modify it. Thank you for your attention.